Well, hi there. Thanks so much for showing up for your learning. It's Mr. Jennings, and we are looking at non-right angled triangles, okay? Most triangles aren't right angled. If you create a random triangle, very unlikely that it's going to have a right angle in it. Humans make a lot of right angled triangles, though. We really like square corners, and it certainly makes the math a lot easier. All right. So if we are working with non-right angled triangles, we need upgraded tools that are a little bit more robust than our SOHCAHTOA. That being said, if you can use SOHCAHTOA in right angled trigonometry, do that. Don't do this. That's a common student error, is overusing the tools I'm about to share with you. They do work with right angled triangles, but they're way more complicated. Okay, so here, label this triangle ABC as angles. So if I call this A, B, C, this is totally arbitrary, just label it that way. And then do little a across from A, little c across from C, and little b across from B. Okay, that's how you generally label triangles. You could do big X, Y, Z and little X, Y, Z, but generally it's ABC. Okay. So that's how we label these triangles. And then the cool thing is, doesn't matter the angles in this triangle. This here is always true. Okay? If you take little a, the ratio of little a to the sine of angle A is the same as the ratio of side length B to the sine of angle B. Okay? But that's also the same ratio as little c to the sine of angle C. All of these give you little mini formulas that when you know 3 of these pieces of information, you can find the one missing piece of information. Like let's say I'm interested in sides A and B, so I have my little formula there, and I don't know this, like I don't know that side length, but I do know that side length and these two angles. See, I've got these pairs of information that cross the triangle. That pair of information is all known. This one has one unknown in it, so we can then solve. Okay, that's how we can then solve, is because we have like that equation with one unknown solvable. There's also another reworking of this formula, okay? And this is useful to also write down. You could also flip all of these and put your angles on the top. The ratio of sine of that angle to that side length is the same as sine of this angle to that side length is the same as sine of this angle to that side length. It's all the same. All right, and we can build lots of mini formulas that way, but these are the two that you want to remember. Use this one when you're solving for sides. And if we're solving for angles, use these ones. Okay, so that's pretty clear. Let's try that. Any two can be used. So you could use like this one and this one, no problem. They're equals, equals, equals. They're equals all the way through. So any pair of two of those ratios will be your formula that you'll use to solve problems. Sorry, let me take a sip of ginger kombucha. It's delicious. All right, let's keep going. So let's use the sine law to solve for the missing side in this triangle here. Okay, so I know this angle C. I know this angle B. Oh, and I know this over here. This would be little b, is 14.2. This is little c. And this is little a, okay? If I'm interested to solve for C, this is what I would do. I would write out my formula. C over sine C is equal to, that's big B, that's little b. Little b over sine big B. Okay, and now I sub in and solve this for the missing side. Okay. I also noticed, one thing I checked is This is not a right-angled triangle, so I don't just need SOHCAHTOA. I need something bigger like sine law. So let's go ahead and sub in. C is unknown, so we're going to keep that as C. Sine C is sine 73, so we just write that in. Sine 73 is equal to, B is 14.2, so write that in, 14.2, and divided by sine 15. Okay, now, wouldn't it be nice if this equation was just C equals, hey, look, see how I did that there? I'm a little out of space for the C. So C equals and then some stuff. We can get that equation by rearranging this algebraically, okay? Multiply both sides by sine 73. Why did I do that? No, seriously, why did I do that? Why did I multiply both sides by sine 73? I know why you did that. You did that because you were dividing by sine 73 over here, and the opposite of division is multiplication. So that's why you did that. And then these cancel, and then this expression over here is what C is equal to. So C is equal to 14.2 multiplied by sine 73, all divided by sine 15. Okay? Well, thanks. That was very clear. Good. Got it. He's on the ball, that one. So now let's punch that in our calculators. You need to practice punching this in your calculator and figuring out how to work your calculator. That is a kind of Google question. Like if you don't know how to work your calculator, ask Google. Google's good at that type of thing. Say, how do I fix my calculator to work with trigonometric ratios correctly and stuff. But anyway, I can also help you. I'll sit down with you and help you if you really need help. Okay, so let's punch it. 14.2 multiplied by, I'm going to take the sine of 73. So I have to write 73 and then push sine. That's the sine of 73. It's 0.95. I'm just going to push equals, and that's what's on the top of my fraction. And I'm going to say divide by 15, but I take the sine of it. So I'm going to take sine 15. That's sine 15, 0.25. Then I push equals. There. 52.46. So we're going to keep the same number of digits as we have there, which would be one digit after the decimal place. So that's 52.5. And circle it. That's our answer. Okay? So you try this one on your own and see what you get and show me in class. And then I will know that you can do this type of thing too. Okay, let's keep going. All right. This one down here, if we want to solve for x, well, that's very interesting. Okay? What are we going to do to solve for x here? Problem is, I'm just going to remove all that. Oh dear, it's not going to be in the notes. Do it this way. C is equal to 14.2 over sine 15 multiplied by sine 73. Okay, that's the expression that I punched in my calculator. Okay, but now down here with this one, C, it's this slightly trickier, okay? The reason it's slightly trickier is I don't know this angle yet. Okay, suppose I name this big X, and this is little x, and I name this big Z, and this is little z equals that, and then this is big Y, and this is little y. Okay, and I want to know x. I need to find x. So I set it up, you know, like z over sine z is equal to, because that's where I've got like, you know, I would love to say we could do this, right? Because if only we had that. We do have that. Okay, we do know that angle z, all right? X plus z plus y equals 180. It's a triangle. So we can find a missing angle if we know 2. Okay, so we know 2. So let's go ahead and find what that is. X is 56. Z is z. Y is 43. 56 plus 43 is 99 equals 180. So I'm going to subtract. Wait, how do I solve this one? The opposite of addition is subtraction, so you should subtract 99 from both sides of the equation. Man, I have some sharp students. Minus, it is indeed 99, so I subtract 99 from both sides. That makes these 0. And we get this beautiful line, z equals, is that 81? It is indeed 81. So let's improve our diagram. Just put it on your diagram once you find it. 81 degrees, okay? That was the little missing thing we needed. Now we know this hot dog of information. It's like a hot dog that lies across the triangle. And we can use that along with this pair to count them. 1 known piece of information, 2 known pieces of information, 3 known pieces of information with 1 unknown. So solvable. 1 unknown, solvable. So we have that's equal to x on sine x. And now we sub in. Okay, so z is 38. Sine z is sine 81 is equal to x divided by sine 56. Oh, geez. Isn't it annoying that we're dividing x by sine 56? I sure wish someone would tell me how to isolate x in this case. You should divide by... You're wrong. You should multiply, by sine 56, because that would be the opposite of dividing by sine 56. Very good. I don't happen to know what sine 56 is, but I do know that sine 56 divided by sine 56 is 1. So that would be gone. So I can multiply here a sine 56. Put that in brackets. Cool. Cancels, cancels. I now have isolated x. Beautiful. And let's just punch this on our calculator. Okay, let's go. Maybe I take sine 56 first. Sure, fine. 56. Take the sine of it. Oh, it's a number slightly less than 1. I seem to always be getting sine values that are slightly less than 1. Good. That's sine is always 1 or less. Okay, multiply this by 38 equals 31.5, and then I divide by 81. No, I don't divide by 81. I divide by the sine of 81. There's sine 81. It's extremely close to 1. Okay, and then I get equals 31.89. So that's 31.9 for sure. Oh yeah, 31.9. And it's centimeters. So circle it. That is x. X equals 31.9 centimeters. Once we solve it, you just put it on your diagram. Call attention to that. Cool. So that's how sine law work. Let's do this one here where we're solving for angles. Okay? Oh, we would really like angle A. So we set it up this way now. Instead of setting it up A on sine A, which would be a recipe for a small headache, minor, okay? We're going to set it up this way. Sine A on little a, 26, is equal to sine C on little c. Okay, this is A. I should write in my formula there. And then I go ahead and, oh, I have another participant here. What a joy. Okay, so we're going to just sub in everything we know. So we have sine A, we don't know that yet, divided by 26 is equal to sine 53 divided by 37. Okay? Gee, I really wish we could isolate sine A. Sorry, just one sec.
So can you set up Nintendo?
No, I can't set up Nintendo, man. I'm in the middle of a math lesson. I will set up Nintendo at the end of this math lesson. So, that was riveting, I know. But here, I really wish we weren't dividing by 26, so let's multiply by 26. So multiply both sides by 26. This cancels that. That's why we did that. And then we get the next line. Sine A is equal to this stuff. 26 multiplied by sine 53 divided by 37. Well, I really wish we weren't solving for sine A. I wish we were solving for A. So we go ahead and take the inverse sine of this whole thing. Inverse sine all of that. Okay? And that's going to solve for A. We basically did do sine inverse of sine A, which cancels that operation on that side. It's kind of your inverse operation there. So it's an inverse function. So now that's what we punch. Okay, so I can punch that. Watch. Clear. First, I need to solve for this number on my calculator, and your hand calculators are a little different. If you punch exactly what you see there, you're going to get the right answer. If you punch something different without brackets, it's probably going to tell you math error, and you're going to be like, Mr. Jennings, it's not working. You didn't punch it exactly like that. Okay, so this is what we would do. I'm going to go 26 times the sine of 53. There's the sine of 53 equals 20.7 divided by 37 equals. That's the result of everything in the brackets. Okay, so I can even write another line here. Equals sine inverse of 0.56 blah, blah, blah. 5612, yeah, etc., etc. I'm not going to retype this number. This number is very accurate. So let's do sine inverse of that number. 34 degrees. Of course it's 34 degrees because Mr. Martin was a Fibonacci lover. Okay, so A equals that. A equals 34 degrees. And now we know it. 34 degrees. So that's how sine law works. We can use sine law, and it's the simpler one. It's simpler than cosine law. You will prefer to use sine law when possible. Okay? You will use sine law when you have one of these pairs of information, meaning you know everything about one of these ratios. You know this angle, and you know this side. Okay? Then this becomes a powerful tool. You can feed it one of these, even with an unknown in it, and then the unknown can become known by doing algebra. Cosine law, on the other hand, is a little different. Let's first write down our formula, okay? And notice here, in this one, we don't have this pair anywhere, okay? There's an unknown in each one of those pairs, all right? I don't know this. I don't know this angle, and I don't know that angle. So I can't use cosine. I can't use sine law because I don't know one of these whole ratios, okay? But what I can use is this formula. A squared equals B squared plus C squared minus 2BC cosine of big A. Okay? That's just your Pythagorean theorem. So if this is a right angled triangle, this actually ends up being 0. And cosine law is just an upgraded version of Pythagorean theorem that works for all triangles. Cool, right? So this way we can solve for little a. Because, hey, look at this. This is little b over here, and this is little c, and we know we just need b, c, bc, and the cosine of a. So these three are all known. So we can use this in what are called side angle side situations. We know a side, we know the angle in between, and we know another side. In those cases, we can use that to solve for the other side that's connected by those two sides where we know the angle. Cool, right? And that situation comes up quite a bit, so very useful. So this is, little c, c equals, and b equals, okay? The thing that you want to make sure is that you have A and A set up here and here. All right? If this happened to be Z and little z, then you would have Z squared equals blah, blah, blah cos Z. Okay? Don't be too fussed about the letters. Letters are totally arbitrary. So that's one of the rearrangements of cosine law. We will use this to solve for sides. But we can also use cosine law, just like sine law, to solve for angles. Let's do that. Okay, let's do that by rearranging this formula. Okay, so I'm going to just isolate cosine A. is what I'm going to do. So the first thing I'm going to do is subtract b squared and subtract c squared from both sides to move them away. Okay, and then we're going to get this next line here. I'll do all this in blue so that you can see the beautiful formula there. Okay, that's the one you're going to use. So then we have a squared minus b squared minus c squared equals negative 2bc cosine of a. And now we want to isolate cosine a as much as possible. So let's go ahead and divide by negative 2bc. All right, dividing by a negative just flips the signs of everything on top. This cancels this. Hooray, we have isolated cosine of a. Okay, so we have equals cosine a on that side. And on the other side, we have negative a squared plus b squared plus c squared, all divided by 2bc. Okay? Are you following? And now this is what you can memorize. Go ahead and memorize that if you want. I'm going to write it over here because it's useful. Cosine of A is equal to b squared plus c squared minus a squared, all divided by 2bc. It's the same formula. It's just rearranged for this angle. And I don't have it memorized. I just build it again from this one I have memorized. Solve for angles with this one. You can memorize it. You can put it on a formula sheet. Okay, you heard it here first. There's going to be a formula sheet for this test. But I would suggest having the algebra skills to rearrange this stuff because I can't remember it and I'm good at this stuff. Can you remember it? You're getting good at this stuff. But to me, memorizing a bunch of stuff does not being good at math make. Let's solve some problems, everybody. Wrap this video up. What time is it? Oh my gosh, almost 5. I gotta go make tacos. So, here we go. We're gonna solve for a here, and we're gonna do that by copying out a squared equals b squared plus c squared minus 2bc cosine of a. Copy the formula out every time. Good idea, right? So now let's sub in. We don't know a, so it's a squared equals 36 squared plus 26 squared minus 2 times 36, subbing into brackets, times 26 times cosine of 53. Okay? And now, get out your calculator and crunch that. Clear. Okay, so we've got 36 squared plus 26 squared minus 2 times 36 times 26 times 53, but I take the cosine of it, equals 845.4. Gee, I was expecting something smaller. 845.4 equals a squared. Oh, right, a squared. So now I have the pleasure of taking the square root of both sides, and that will solve for a. That will be my side length. Clearly, this cannot be 845, but if I do square root of that, I get 29. And 29.07, 29 centimeters is totally reasonable, right? That's really in the ballpark for these. It matches my guess that I made when I started, okay? So you can absolutely start these with a guess and then check against your guess. 29 centimeters. Done. But what if we want to, so then you try this one and tell me what you get and show me your solution. Start with a guess and see if it matches your guess at the end. Okay. Examples, I'm going to skip over that, but we're going to do that in class together, okay? You need to, oh no, I'm going to talk about it. I'm going to talk about it right now. It's important. There's going to be people who are lost. Okay, particularly because we're talking about bearings, okay? When we're talking about bearings, north is a bearing 360 or a 0, okay? So that's like 0 degrees. So a bearing of 36 degrees is like over this way. 36 degrees, and a bearing of 264 is like pretty much that way. Okay? That's 264. All right? Wow. Well, 264, it's very nearly a full turn, but it's not quite a full turn. It happens to be 96 degrees short of a full turn. So we can also mark this one here as 96 degrees. Okay? So that here is going to give us the total angle in between these two bearings. So now I'm going to redraw another diagram. Two hikers leave from the same spot at the same time. This one goes 36 degrees that way, like a little bit east of north. And this one goes like a little bit like southeasty, kind of that way. We know this here is 132 degrees. Okay. The first hiker goes this way. This is first hiker. And this is second hiker. And the first hiker is at a speed of 5 kilometers an hour. And we want to know how far they are 2.5 hours later. So this one will have gone 12.5 kilometers. How did I do that? I did 5 times 2.5 and got 12.5 on my calculator. I used my calculator while you weren't looking. That's how I do that type of stuff. Okay, and then the other one is traveling at 6 kilometers an hour. So 6 times 2.5 happens to be 15. So this one is 15 kilometers. So I got my side lengths and I got my angle in between, and I want to know the distance between them. So I'm basically solving for A. And so I set it up this way. Cosine A, oh geez, not cosine A. Let's do this in black so it stands out. And I'm going to use this space because if you're struggling with that, then I suggest using your calculator. Okay, A squared equals B squared plus C squared minus 2BC cosine of A. All right, and I just verified this is my angle A. And this is my side length A that I'm solving for, so I have that set up right. A squared is equal to 12.5 squared plus 15 squared minus 2 times 12.5 times 15 times cosine, of 132. Now we punch that on calculator. I mean, I can do that in my head, but you can't do that in your head. No, I'm just kidding. I can't do that in my head. 12.5 squared, that looks right, plus 15 squared, that's 225, minus 2 times 12.5 times 15 times 132, but I take the cosine. Cosine can be negative here, don't worry. That's equal to this, and then don't forget I take the square root, 25.1. A equals 25.1 kilometers. So after 2.5 hours, they're 25 kilometers apart. They're moving apart at about 10 kilometers an hour each, which shouldn't surprise us. They're almost moving in a straight line apart based on this angle here. And this one's moving at 6, this one's moving at 5. That's a total speed of 11 if they were moving in exactly the opposite directions. But because if they were moving in the same direction, it'd only be 1 kilometer different. This way it's about 10. This is very cool. All right, cool. Now, let's look at one where we're solving for the angle. Let's see if I can remember my formula. Cosine of A is equal to B squared plus C squared minus A squared all over 2BC. Let's see if I have that right, because as I was bragging earlier, I don't have it memorized, but you can bet I may have it memorized after doing this lesson. And then we just sub in and solve, right? Cosine of A is equal to B squared plus C squared. This is little c, this is little b. Doesn't matter which one you have where. they're interchangeable, 33 squared minus that one squared, all divided by 2 times 23 times 33. And that's what we're going to punch on our calculator. Cosine of A is equal to, clear. I suggest you put the top in brackets so that you don't just divide that one. Okay? It's just like the more brackets you use on your calculator, the better. I'm going to put in brackets 23 squared plus 33 squared. No, not 333, clear. 33 squared minus, wait, it's only that much? Yeah, that's right, it's only that much. Minus 28 squared, and the bracket, that's what's on top, divided by, put this in brackets too, 2 times 23 times 33, and that bracket, equals, so put these in brackets as well, is helpful, equals that. So cosine A is equal to 0.549 some stuff. Okay? If I catch people clearing this off their calculator and typing that on your calculator, not only am I going to tell you you're wasting your time, but you're also losing accuracy, because this number, I'm never writing that whole thing down, but it's hecka accurate. Okay, so now I take the inverse cosine of that, and there's my angle. Okay, so A equals cos inverse of 0.549, blah, 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 some stuff, which makes A equal to 56.6, so 57 degrees. And that looks about like 57 degrees, doesn't it? So it matches our guess. Okay, get out of here. Go try some problems, everybody. Thanks for sticking with me for this sine law and cosine law lesson. It was never the plan to do both on the same day, but this gets you practicing, because I wasn't here yesterday, and I don't know if I'm here today. So this is in case I'm not here today. All right, bye for now, everybody. And hit me up with your questions. For sure, I want to chat. Bye.